In the rest of this module, I'm going to provide a very basic overview of the Python programming language. If you have a background in programming, this overview should be enough to help you be successful in the rest of this course and the following courses in the specialization. If you don't have a programming experience or feel like content is overly challenging, then I would encourage you to stop and take an introductory programming class. A colleague of mine, Dr. Chuck Severance, offers an excellent specialization on Coursera called Python for Everybody. You can find a link to that in the course resources. The Coursera system allows you to run Python code from your browser in two ways. First, we can use in-video prompts where a question will come up and you can try and solve that question in the browser. This is new to the Coursera platform, and we're going to try it in the next couple of lectures. Second, the Coursera system has been integrated with Jupyter Notebooks. These notebooks allow you to divide your code up into what they call cells and execute these cells on demand. The nice thing about these notebooks is that they offer a semi-permanent storage for your learning, and you can experiment and play with programming without having to install anything on your computer. All of the assignments will be done in the Jupyter Notebooks, but you can of course download and install Python, Jupyter, and all of the associated libraries you need for this course on your own computer if you'd like. Our tutorial assistant will provide an overview of this process by installing the Jupyter Notebooks locally in the next video for those of you who are interested, and I'll give an overview of how you can use these notebooks in the Coursera environment in this lecture. But for now, let's dig into some basic Python. First, Python is a high-level language, which means it's optimized for reading by people instead of machines. It's also an interpreted language, which means it isn't compiled directly to machine code and, importantly, is commonly used in an interactive fashion. This might be quite different if you're used to programming in something like Java or C, where you write your code, compile it, run it, and watch the output. In Python, you can start the interactive interpreter and begin writing code line by line, with the interpreter evaluating each statement as you write it. This turns out to be very useful for tasks that require a lot of investigation versus those that require a lot of design. Shell scripting is one example of these, and data cleaning is another. While you can write scripts that execute as programs like you might be used to in other languages, we're going to use Python throughout this specialization in this interactive fashion. A common surprise for some programmers coming from a Java or C background is that Python is a dynamically typed language, similar to languages like JavaScript. This means that when you declare a variable, you can assign it to be an integer on one line and a string on the next line. Since there is no compilation step, you don't have anyone to help you manage types. You need to either check for the presence of functionality when you go to use it, or try and use the functionality and catch any errors that occur. The dynamic typing of Python is particularly nice when used in an interactive fashion, as it allows you to quickly set and modify variable contents without having to worry about the underlying syntactic definition of the variable. Okay, so let's jump in with an example. For all of the code examples I'll show you, you'll find an annotated version of the notebook with more comments in the course resources section. You're welcome to follow along with that if you would like, or create a new notebook and actively write code if you prefer. Python is very little boilerplate code. In fact, if you just wanted to set the value of a couple of variables and output the results of these variables added together, you could do so in 3 lines. In this example, I'll write 3 statements. The first 2 set the variables x and y, each to be some integer value. Then we'll do some addition. We can run this cell by hitting Shift-Enter, or by clicking on the playhead icon in the toolbar. The output from the statement is immediately printed. If you were using Python in a non-interactive mode, nothing would print, but since we're using it in an interactive mode, we get the value immediately. What's happening underneath is that the browser is sending your Python code across to a machine in the cloud, which executes the code in a Python 3 interpreter and sends the results back. We can see that after executing a cell, a new empty cell is created for us below. If we just put in x and execute, we get the value of 1. So it's important to know that the Python interpreter is stateful. That is, that your variables exist between cells. Beyond that, if we go back and change something in a previous cell, we have to re-execute the script to make those changes take place. The restart and run all function is particularly useful as it wipes the interpreter state and reruns all of the cells in the current notebook. You'll notice that Python doesn't require the use of keywords like var to declare a variable name, or semicolons at the end of lines, which are commonly used in other languages. Python leverages whitespace to understand the scope of functions and loops, and end-of-line markers to understand the end of statements. Of course, Python has traditional software structures like functions. Here's an example, refactoring that previous code into a function. You'll see the def statement indicates that we're writing a function. Then each line that is part of the function needs to be indented with a tab character or a couple of spaces. Again, because we're in an interactive environment, when the statement is evaluated on a Shift-Enter, the results are printed out immediately below. Here's our first bit of interaction. Why don't you try and change this function to accept 3 parameters instead of 2 and return the sum of all 3 of those? Okay, functions are great, but they're a bit different than you might find in other languages, and here are some of the subtleties involved. First, since there's no typing, you don't have to set your return type. Second, you don't have to use a return statement at all, actually. There's a special value that's called none that's returned. None is similar to null in Java and represents the absence of value. Third, in Python, you can have default values for parameters. Here's an example. In this example, we can rewrite the addNumbers function to take 3 parameters, but we can set the last parameter to be none by default. This means that you can call addNumbers with just 2 values or with 3, and you don't have to rewrite the function signature to overload it. This is an important implication. All of the optional parameters, the ones that you've got default values for, need to come at the end of the function declaration. It also means that you can pass in optional parameters as labeled values. Here's an example of labeled parameters. We can rewrite that function so that there's 2 optional parameters. If we want to call the function with just 2 numbers but also set the flag value, we have to explicitly name and set the flag parameter to true when invoking the function. By now you've also seen the use of the print statement. We're going to dive into strings in more detail, but print will take an item, try and convert it to a string, and print the output. We don't use this much in the interactive mode of the interpreter, but it's useful when we want to print out multiple values for a single cell. Okay, a final word on the basics of functions in Python. In Python, you can assign a variable to a function. This might seem either completely normal to you or completely odd, depending upon your programming background. By assigning a variable to a function, you can pass that variable into other functions, allowing for some basic functional programming. We'll talk about that a little bit later on in the course, but here's an example where we define a function to add numbers, then we assign that function to a variable, and then we invoke the variable. That's a whirlwind tour of functions. Here's a poorly written one. Can you fix it?